Today we're in lesson 8.2. Today we're in lesson 8.2, using random samples to describe a population. Yesterday we talked about samples being biased and unbiased. All right, does anybody remember the two criteria? We said two things needed to happen in order for a sample to be unbiased. Can anybody raise your hand and tell me what those two things are? Can anybody tell me? Colin?
It needs to be random.
Yep.
And represent the population, so not just a target demographic.
Yes. What's the word I'm looking for, Samuel? Large. Okay, big. Okay, so that was this hand motion. Okay, so it has to be random. It has to be large enough to represent the population. So if you want to know the opinion of the residents of the state of Florida, you're not going to ask 10 people. Okay, that's not an accurate sample. So today we're going to use random samples. We're assuming that they are unbiased. Okay, but the goal here is to make the sample large. All right, and there's a strategy that we're going to use to do that. All right, so in example 1, what I want you to do is turn in your books to page 332. There's a scenario that they talk about, and I wanted to put it on the slide, but I kind of ran out of room. So I just need you to use your books to kind of read along with me. There's some important information in here that will help us kind of move through solving this. Okay, it says you and a group of friends want to know how many students in your school prefer pop music. There are 840 students in your school, and each person in the group randomly surveys 20 students. The table shows the results. All right, so here I have my results, friend A, B, C, and D. Okay, so what happened was I went out in the hallway and I asked 20 people, hey, here are your choices. And which type of music do you prefer? Okay, obviously this is all just fictional, and we're assuming it's all Christian music as well. All right. So here are my results. Okay, and what category am I focusing on? What category am I focusing on according to the scenario? How many students? Pop music. Very good. Okay, so pop music is my focus. I easily could have chosen one of the other categories and run all the data. Okay, and it would have been completely different, but my focus is on pop music, okay? So what I'm going to do is I'm going to calculate the percentage here. If 13 out of, how many people did I survey? Just me? 13 out of 20 preferred pop music. What percentage of my sample preferred pop music? All right, so I'm just going to kind of write it in here so you can see what we're doing. 13 out of 20. All right. Now, we talked the other day about actually a mental math way to solve this. Do you guys remember the mental math way?
No.
If, Isla? If your denominator can go into 100, how many times does 20 go into 100? 5. You can take that number and multiply it by the numerator. What's the other way I could calculate the percentage? What's the other way? To divide. 13 divided by 20 and change it to a percent. Okay? So either way, 13 over 20 is what as a percentage? 65%. So I want you to write that to the right of the 13. What am I saying here? I'm saying that 65% of my sample preferred pop music. But again, in order for a sample to be accurate, what do we say? It needs to be large, right? How many students were in the school? A lot. 840. So is 10 accurate? Could I say, okay, 65% prefer pop? Okay. I have a long way to go because I need a larger sample, but instead of wearing myself out trying to ask all these people, we split the work among the 5 of us. Do you see what we're doing? So we're collectively trying to find an accurate sample, okay? So what we're going to do is we're going to go down for each person. What is 8 out of 20? What percentage? We need to calculate all of these percentages, okay? So just like I calculated my percentage, I want you to do friend A, B, C, and D. Okay, so next one is 8 over 20. Okay, so 8 times 5 is 40%, or if I did my division. All right, 10 over 20. Okay, did anybody catch that was 1/2? All right, 50%. I had some students that were like, oh, as soon as I put in my calculator, I was like, of course, 50%, but we just kind of get in that habit of just putting it in our calculator. All right, so of course, this one's going to be 50% also. And what about 9 out of 20? 45%. Okay, so now I have all these percentages. I know that this is a percent of my sample. So if I'm trying to predict a future amount, all right, this is, I think, throwing it back to chapter 6 now, I'm going to use an old friend, the percent equation. A equals P times W, okay? And A is going to be the part of the population, all right? We know that how many students are in the school? 840. So the part equals the percent. So we'll start with me, 0.65 times the whole, which is 840. Okay? So I'm going to take each of these percentages and multiply them by the total number of students to predict how many students in the population would prefer this kind of music. All right, so 0.65 times 840 equals what? 546. So that's what I put down here in my estimate in this table at the bottom. So what I want you to do now is take your percentages and calculate your estimates for all of your friends. Because again, I can't just say, oh, well, based on the 10 people or the 20 people that I asked, it's 546. Because again, that sample's not large enough. But I can take all my friends together and that sample would be big enough. Okay, so divide and conquer kind of is the mentality here. All right, so what did you get for friend A?
336.
336. What did you get for friend B?
420.
Okay, friend C?
420.
And friend D?
378.
378. So what I'm going to do now, okay, so I made an estimate, all right, based on each one of my friends, but now I'm going to put them all together, and here's the second part of the question. It says, describe the center. Describe the center. So let's stop there. The center means the average, okay? So the average, I have two choices. I can either do the mean or the median. Now, your book in this lesson kind of goes back and forth between mean and median. I'm going to kind of start here, all right? Typically, the mean and median will be close in value as long as you don't have extreme values, okay? And what I mean by extreme values, this example isn't the best example to say something about extreme, but like, what if I just happened to go out in the hallway and I asked 20 people and all 20 of them said one category and nobody said any other category? Then things kind of start to get a little wacky, okay? So the mean does not do well with what we call outliers, values that are just kind of random and outside of all the other cluster of values. In this case, we don't really see a whole lot of that, okay? So the mean and the median will both be close. Now, the book does the median, so we're going to do the median. In the next example, I think we'll be able to understand a little bit better kind of what I'm talking about here about the difference between the two. All right, so we're going to describe the center. Does anybody remember the rule? Okay, so this is totally a review. I have not taught you this year for finding median. Finding median. I know you got to rack your brains. Median. Joel?
Subtract the largest and the biggest.
Okay, that's the range. We're getting there. Kayla?
Add and divide thing?
No, that's the mean. Alexa?
You have to put the numbers in order and then you find
Yes. Put them in order. Okay, what's the smallest number? Okay, so median. All right, I'm just going to change the color of my pen. Median, all right, here we go. We got to list them in order. 336. What's the next one? 378. What's the next one? 420, 420, and 546. Okay? And the median says, okay, now I'm going to take all my estimates. I'm going to go from the outside to the inside, and I'm going to say that my median is 420. So this is the most accurate guess as to how many students in the population would prefer pop music. So I'm going to say 420 students. All right, now it says describe the variation, okay? So when I think of something varying, what does that mean for something to vary? How do the values kind of differ, right? So the variation is the range, okay? Range is what we call the variation. All right, so the range of values is my biggest value minus my smallest value. What is the largest number out of all my estimates? 546. What is the smallest number? 336. So my range or my variation is 210 students. Okay? All right, so if you ever have a question, homework or quiz or test that says describe the center, go for the median, and describe the variation, you're going to go for the range. Okay? And again, what are we trying to do? We're just trying to predict a population. We can't ask 840 people what they think. But if we ask 100 of the 800, yeah, I mean, for some reason, pop music is pretty popular in the school, isn't it? Right? Because 420 is about what of 840? Half. It's about half. So it is half. Yes, it's 50%. All right. Okay, so now let's do the next example. We're going to do one more of these. Okay, we're going to take just a little bit of a different approach. All right, so you want to know the mean number of hours students with part-time jobs work each week. So assume these are high school students. And let's get even more specific. Let's say that these are all 6 of these schools are west side schools, like on the west side of Jacksonville. Okay, I don't know what schools they are, but I know there's at least 6. Okay, so school A could be Trinity, school B could be Eagles View, and we could go down the list of what schools these could be. All right, again, this is all just fictional. All right, so we go to each school and we ask 10 students at each school, how many hours a week do you work? Okay, so what we're going to do is take the mean, which is the average of each school. So we're going to take school A and add all these numbers together. 6 plus 8. Now, I would encourage you to use some mental math skills here. Like, I know that, let's see, 4 plus 6 is 10. 10 plus 10 is 20. And you could kind of keep going. 8 plus 7 is 15. So that makes 35. All right, so this is a really great opportunity for us to sharpen some mental math skills. Put those calculators down. Okay, I promise you, once you get your total, you're dividing by 10, that's easy. You'll be able to divide them by 10. Okay, so let's try to put those calculators down. Okay, all right, so let's try to kind of use some mental math strategies here. Okay, does anybody have school A? What was my total? 70. Okay, so if you didn't get there, just go ahead and write it down. Okay, 70 divided by how many were asked? 10. So my mean for school A is 7 because I divide by the number of students asked. All right, 7. But again, I can't say, well, I asked 10 people, so the average number of high schoolers our average number of hours per week that they work is 7 for the whole west side because I asked 10 people that go to Trinity, right? Okay, it sounds ridiculous. So what we do is we go to more schools. That's what B, C, D, E, and F are. All right, so obviously this is going to get very repetitive. So can I give you, has anybody already done B? No. Okay, so let me give you B. When you add them all together, it's 73. Okay? I'm going to give you C, 77. And I'll give you D, 50. Okay? Well, I mean, that's kind of showing, no, that's not the answer. You have to do this division to get the mean, okay? So go ahead and finish adding E and F. Let's get all our means. I'm just going to kind of walk around and check on you guys, and then we'll talk about what to do next. Yeah, it's just kind of repetitive, right? Okay, so 7.3 is my mean for B, 7.7 for C, 5 is D, E is what? 8 is my mean, and F, what's my mean? 9, okay? So students at school F, they're working a little more. All right, so these are my means, but again, in order to get a more... I just lost my internet. I'm so sorry. Okay, in order to get a more accurate picture, okay, there it is. All right, just erased a little bit. I need to now, do you guys remember what we did with all of our estimates in the last example?
Yeah,
We kind of pulled them all together, right?
Yeah.
Okay, so I could put these in order least to greatest and find my median. Okay. Actually, these are means, so I actually would have to go back. So let's just find the mean of these because it was the mean of each category. Let's find our final mean. We're going to call it the final mean. Then we'll talk about the median. Okay? So the final mean would be to take all 6. What do you think I'm going to do? I'm going to add them all together. Okay? And when I add them all together, I get 44. Oh my goodness, what just happened? It just erased all my numbers. No. What in the world? Oh my gosh. All right, I'm just going to write the means. I have no idea what just happened. 7, don't you laugh. 7.7, no, 7.3. 7.7. Oh my goodness, what in the world? It's gone on my screen, I'm telling you. Something, it's got to be something with the internet. All right, so it's kind of messing up my recording right now, so I'm just going to finish writing them back in. Just ignore the screen. All right, 5, 8, and 9. Okay, so when I add all those together, I get 44. Final mean is 44, and then I divide that by how many do you think? 6. Now, it is kind of a weird repeating decimal. It's going to be about 7.3 repeating hours. Okay? Now, because we just calculated median in the last class, or not in the last class, in the last example, I'm not going to make you go back through. This is what you'd have to do. Put all those numbers in order and find the median of each one.
Wait, you're mean like all
That would be sad.
them in order?
Yeah, so we're not going to do that. We're not going to do that, okay? But I do have a point I need to make about the median, okay? So the median, I will tell you, the final median is 7. So we need to talk about the comparison of the values, okay? So if you were to have gone back and put all the numbers in order and found the medians, you would have found that the overall median is 7 hours. So how do these two values compare to each other? Would you say they're close in value or not? Okay? So in this case, either the mean or the median would be acceptable. So you say, well, you know, it sounds like both examples we learned in class today, they were about the same. So in what kind of a scenario would the mean actually throw off that measure of center? It would be if you had something called an outlier over here in the data set. Let's say I went to school A, and in school A, instead of this 10th student working 8 hours a week, what if student number 10 worked 40 hours a week? Okay, so student number 10 has a full-time job. Maybe they're a senior in high school, they only take one class, and they actually work 40 hours a week. What is that number going to do to your mean for school A? It's going to pull it up. Let's say, now we don't have to calculate it. Let's just say now it makes my mean 10 hours per week for school A. Well, look at the other students. Is that an accurate measure of center? How many students in school A, other than the 40-hour-a-week kid, even works 10 hours? Only one. So the mean throws off your measure of central tendency. When you have these values called outliers, it pulls the average up or down. Okay? So the same thing would go if you, went to school F down here, and someone, instead of 10, they said, well, I don't work at all. I work 0. What's that going to do to your mean? It's going to pull it down. Versus if it was the median, you just put them on the outside, and what happens on the median? They cancel out. So they don't affect, they're not affecting that center. Does that make sense, guys? So that's a little bit beyond where we are in pre-algebra, but that is really important for you to understand for measures of central tendency. Okay? That's really important. All right, so other than that, I'm going to kind of backtrack off that. All right. We are pretty much good for 8.2, so that'll be it.